Very good morning to all of you, and welcome to Air Quality Management series. Today we have 40th lecture. Thanks to Mr. Priya to the talk for this 40th lecture. Just wanted to give you a brief about this Air Quality Management lecture series. We started this during 2020, and connecting people in the COVID period. The idea was to give a platform for young researchers, scientists, engineers to work on this air quality management issues. And this is one of its kind in India, connecting across the globe, first working in the area of air quality management. Now, you see that we have excellent speakers. Every month we used to reach out to various colleagues working in the expertise of air quality management. We started this lecture with B. Gupta. You see that we have a mix of colleagues from India and international arena. These are all lectures, so you might be knowing that for every year we can have only 12 lectures. So today is the 40th, means that for 40 months they are continuing to have this. Just to give you some additional thoughts, when we are having a forum, we also wanted to think there will be always some commonality with us. So we thought also create some kind of an association where people think same can also work and do some service to the society. So with that interest, objective in mind, we started an air quality management association. Our director inaugurated this we started this air quality management association. At that time, the chairman of the so if you are interested to become a member, so you can put, also you can type air quality management associations. So coming back, we always look at it. One aspect of lecture series is to bring connecting expert with the student community, these engineers, and this aspect is also to make development network. And the other of this UKRE project, Clean Environment for Planetary Health. Yeah, we have a larger network which works on various environmental issues, and particularly with a key idea of engage, identify, scan, build, and integrate. So all these things are part of this network to make sure that engage community, then identify which problem works and what is the solution that needs to be addressed, and how do we strengthen the collaborations, cooperations. Capacity building is another aspect. Also, create resources to manage the various. Again, maybe knowing that it's not a standalone exercise, but we are constantly working towards air quality management. You know that this is a last year conference, and we were going to have a ninth conference air quality management. Just now, next about 1 month back, we organized this conference, the Indian International Conference on Air Quality Management, several universities collaboration. So we are going to have this year again in December. Of course, you know that December is very challenging for Chennai because we also could get 2 leaves. Okay. So, but we were thinking of organize during the second or third week, and we will let you know the details. So this is another opportunity for you to share. Now coming to today's talk, all of you are waiting, and I'm very glad that Priya Rajagopalan, she's from Post Power Research Center, Associate Dean of Education of School of Property. I mean, so that now everything's talking about property. Even if you go to a big hotel, they call it as a property. Okay, so it's a property, your house is a property, living environment is a property, construction and project management and RMIT in Australia. Now I ask Gopika to introduce. Thank you.
A very good morning to everyone present. The lecture for today is given by Professor Priya Rajagopalan from RMIT University, Australia. Professor Priya is a building scientist, director of the Post Carbon Research Center, and Associate Dean of Research and Innovation at the School of Property, Construction and Project Management, RMIT University. She obtained a Bachelor's of Architectural Engineering degree from NIT Calicut and Masters of Science, Building Science and PhD in Building from the National University of Singapore. Her research interests include building energy efficiency, indoor environment quality, urban heat islands, and citizen science in monitoring, mitigation, and adaptation. She has coordinated several projects in building performance for various climate zones and has published more than 110 scientific papers. She is the past president of the Architectural Science Association and editorial board member of the prestigious journal Energy and Buildings. The talk for today is titled Building Performance and Indoor Air Quality Research, Trends and Innovations, where she will be covering topics related to enhancing indoor air quality for vulnerable populations, optimizing comfort and IAQ, citizen science and community engagement research. Ma'am, we welcome you.
Thank you very much, Professor Shiva, for introducing and inviting me here. Yeah, so good morning. So it's really a privilege to be here, this institution, IIT Madras, and to be talking in front of you. Many thanks to Professor Shiva Nagendra for inviting me here. And I'm here part of the collaborative project, for health, which is between a collaborative project with IIT and many institutions, including Australian National University and RMIT. So, as Gopika introduced, I did my undergraduate study from NIT Calicut, and then my master's and PhD from National Institute of Singapore, and have been living in Australia for 15 years now, and I've been working with RMIT for the last 7 years. And currently heading the post-carbon research infrastructure and built environment research center, which is a new research center established to promote cross-disciplinary research. That is what the focus of many of the universities in Australia. How do you do interdisciplinary research?
Share it. Share it.
Okay. So in Australia, before we do any event, we the acknowledgement of the country. It's basically to acknowledge the indigenous people who are the traditional owners of the land there. Just to acknowledge that we are living and working the ancestors, elders, past and emerging people that the area. And this is something we do every before we start and just want to let you know. So if you haven't heard about RMIT University, it's located in Melbourne, Australia, one of the most livable cities in the world. And the university is very much a practical university in terms of the teaching is more applied. Teaching, I would say, is more applied than theoretical. So, and in the architectural and built environment discipline, this is quite reputed and ranked 25 in the world under QS ranking by subject of architectural built environment. So, if you can't find, the School of Property, RMIT is quite big, very diverse, and there are 3 different schools. There's the School of Architecture, School of Engineering, various disciplines of engineering, civil, mechanical, computer, all sorts of engineering come under the School of Engineering, and we are in the School of Property Construction and Project Management, and very much it's like the accredited courses. So there is a Bachelor of Construction Management, Bachelor of Property, and Bachelor of Project Management, and have got accreditation from various industry organizations, including the Royal Institute of Chartered Surveyors, Chartered Institute of Building, Australian Institute of Building, and many others. So today in my presentation, I will just talk about the university and some of the case studies, some of the projects we have been involved in terms of air quality management and community engagement and community participation in research. So these are the industry associations. The school is actually organized with, and they are part of the school advisory committee, and then give suggestions and advices about what is the growing trend in the area in terms of construction and engineering. So we have few master's program, Masters of Project Management, Master of Property, Master of Energy Efficient and Sustainable Building. That is where I'm teaching most of the courses in the master program. And also there is Master of Occupational Health and Safety, and it's very much associated with what the industry is demanding at the moment. And we have a research agenda, which is how do we actually plan for the next 2 decades, 20 years of, and looking and addressing the global mega trends in the industry and for the community. And there are very high level areas which the university is trying to address, thinking about care of futures, talking about equity, healthier futures, talking about how do you provide health to the whole population, and also creativity. So RMIT design and architecture is quite advanced for the future. So design thinking comes into everything. And how do you make the future resilient and secure, and which is very much related to the IT, computer science, cybersecurity, and also sustainable futures and connected futures. How do you connect communities? And all the areas in the university is actually aiming towards achieving this plan. And in all the research, teaching, and engagement, we need to actually address each of one or more of those niche areas identified by the university. So in research, looking at the excellent innovative research, we had an opportunity to see how the masters and PhD students, the amazing work we have been doing, very much into fundamental research and some applied research, So here the university has been looking into how do you make sure you are doing impact, you are creating impact for people by doing your research. So the research doesn't just stay, in the library as journal articles or only for researchers, but how do you make it impactful? How do you communicate the research to general public who don't really have any scientific literacy? And the impact will be about, so not all projects will have an environmental impact. Some of them may be having more a social impact, and some of them may be having an economic impact. And how do you actually measure this impact in terms of, so most of the research we'll be doing, there is an impact created, but normally we are very bad in measuring the impact because we don't really evaluate and monitor how much our research has actually impacted community positively. And because that takes time, because some of the research which you will be doing now, maybe it takes up to 20 years for it to become, actually implementing in the practical, because you need to go through all sorts of the IP requirement and patent, and all that takes time. And by the time it is applied and people know about it, people started using it, takes time. And maybe by the as researchers, we have moved on to another research. So we kind of forgotten about what we have done. So the universities are actually trying to map out and measure the impact. So for creating impact, what is being identified now is you work in your own silos. Like, I'm working in one particular area of engineering discipline, and I don't really want to know what others are doing because I don't really have time to find out what others are doing. So the idea is to make sure you work, so I mean, by naturally our researchers are very much want to do our own area because that's how you can go in depth. And the latest trends in research is how do you make it cross-disciplinary, multidisciplinary, so it becomes more innovative, and it can adjust all those three: environmental, economic, and the social aspects more easily. So the research center we have just created is basically how do you bring people from various disciplines together. So this center actually is trying to build people from architecture, engineering, construction, computer and geospatial science and social sciences together, and how to create sustainable, equitable and resilient future, because there are a lot of events. We are seeing more and more floods and various fires these days, and trying to address design as a holistic practice, and how with social, political and economic lenses, and how can you visualize alternative futures, and how do you translate this across various contexts, including technical, socio-cultural and industry, and apply in real world. That's where you can really see the impact, and also have a whole life cycle approach for the built environment. It's not just about designing, or it's not about constructing, but also look at the post-construction or the post-operational state. What happens to all these buildings we have created? How do you retain some of them? How do you retrofit buildings, or even if you want to dismantle and construct new, what do you do with all this waste? And as you probably aware, the waste management or disposal of waste is the most important, one of the most important significant problems the whole world is facing now. And I always used to think about what will happen to all these concrete buildings we are making. And if we use sustainable materials, they are quite easy to recycle, or its environmental impacts are but some of the materials, how do you actually think about that right from the design stage rather than think about what we'll do? So when we have identified three different themes in that. So this transition is basically how do you influence the policy makers, the industry change, institutional change, as you know, the institutions are quite reluctant to change, and every time, you know, it goes around a cycle. And how do you, you know, make sure there is social acceptance, and also thinking about the workforce, the skill set, the employment, and looking at the design, thinking about regenerative design, circular economy, monitoring, measurement, modeling, embodied carbon, things like that, and looking into the production of things, how can you have new technologies, many of those emerging technologies like 3D printing, how do you upscale them? You know, there are always a lot of examples of very, you know, very small scale application for these technologies, but how do you make it quite in a large scale? Because you need to take all the people along in your journey. It's not just researchers, but you need to make sure the policy stakeholders, the common people, the workers, construction workers who are at the site, you know, in very difficult situations, how they are going to look at it. And also the procurement is quite important, the supply chain, the finance, delivery, project management, all comes into the requirement. So that's the whole the big picture about, you know, what we are trying to achieve. And I'm going to talk about some projects we have done, keeping these kind of practices, these kind of principles in mind. And one of the projects we have completed, which was quite a, you know, laborious project funded by the federal government in Australia. We call it citizen science in urban microclimate, and one of my research area include urban heat island. It's probably you may have heard about that. And every time I come to Chennai, I can really feel how the intensity of heat island is really increased, and particularly the developing countries are really suffering from the issues. And so we have been trying to look at, you know, how we can involve community into such research. And basically, there are a lot of citizen science projects thinking about ecology, you know, watching various kinds of species, animals, looking at frogs, looking at marine animals, but not very much into the built environment or buildings. So the idea is to, how do you, you know, enhance the interaction between scientists and citizens? And there are multiple benefits of that. The people become engaged with science, they understand science, and researchers can, you know, use the citizens to collect data, and large scale collection of data, which otherwise becomes quite difficult, you know, because of the laborious work and the manpower involved in that. So it's basically improve science, society, and policy interactions, and democratic research based on evidence and informed decisions. So this is, you know, something we have tried to do a mapping of the words coming out in doing citizen science, and they are all, you know, in environment and astronomy and things like that. So this project actually, so the extreme hot days they have, you know, so even though you may think that has been always hot, but if you look at the evidence, you can really see a clear pattern of increasing temperature over the last few decades, and it has got a huge impact on energy, economy, the mortality rates and energy demand, and it really affects the vulnerable population, the elderly people who can't really afford, and the vulnerable population. Another example is construction workers, you know, who are people who can't really afford to do any other job, and they have to be outside in the field. So we were trying to design infrastructure in terms of, you know, what kind of equipment is good, you know, as I said, they cannot be too expensive, because you can't, you know, just, if you have to expect, sometimes you will just lose those equipments. So you have to make sure they are something affordable, even if you lose them, that's fine, it's not really impacting you that much. And at the same time, they can use the data to understand what is the implication of the heat and how can they design or how help them to design some mitigation strategies. So, I mean, if you take the example of Australia, it has always been very hot and always there were, while in extreme hot days, the frequency is being actually increasing. So this is, we call the Australian angry summer in 2013. That actually broke all the records of the hot temperatures. And as a result of that, the Bureau of Meteorology had to come up with a new scale in their temperature because the previous maximum temperature was capped at 50 degrees Celsius. So they had to come up with a whole new color for temperature above 50, and that is how this pink light, the dark pink, came into picture. So since then, it is never, we have never seen a reducing trend. It has been always an increasing trend. So what we are trying to do is, how do you actually design some instrumentation, with keeping all those ideas in mind that it can't be too expensive, but at the same time, how do you calibrate, how do you validate, the measurements coming from a low-cost sensor is something we could, we have some kind of a confidence to say the data is okay, or even if it is not okay, what is the error band, what is the sensitivity of the temperature you are measuring. So these are some of the examples of the measurements. We have the instruments we have designed. So this box, what you are seeing is something we developed ourselves, like we bought all those because we have to actually think about how do you transport that into various places and to distribute to the citizens. I'll come to that detail, but what is inside the box is these kind of equipment, measuring the globe temperature, measuring air and surface temperature, and also measuring the wind speed, and various sorts of things. And also we have the surface infrared gun, which is measuring surface temperature. And we created this something like a shield so that the sensors itself is not really get heated up with the temperature, and also make sure there is enough ventilation so that is not impacting the readings. And we also there are Bureau of Meteorology reference stations, which most of the cities have. But we had our own reference stations, which we kind of set up, using, we call it like a mid-range reference station. They are not as good as the Bureau of Meteorology stations, but somewhere intermittent. And we try to put them into, we are limited by the budget, where do you actually put them. So one in if you see the map of Australia, they are, this is actually the ocean. So this is basically Melbourne area. And the people around the Bay Area or the ocean, they don't feel that hot because always there is coming from the ocean. But whereas people who are in the inland area, there can be a temperature of up to 3 degrees Celsius just on the same time, because it's all desert on the So we had to go through the whole process of ethics application, and we partnered with 22 local councils in this project and all over Australia. So most of them, some 7 to 8 of them from Victoria, where Melbourne is, and some from New South Wales, which is Sydney, and also on the map of that. So it was very, very important that we engage the citizens. If we just send an email to people, nobody is going to respond. So we have to first create a website, and then we have to publicize to, lot of meetings, and discussions with the council people. And some of them may not even respond. Some of them respond because that just happened to be their strategic priority at that particular time of the year. And then we have meetings with them, and then we identify certain areas of strategic importance to the council. And then we use their communication channels, because each council will have a newsletter, a social media platform, groups, community groups. So we kind of use all kinds of communication, and then we got them to send it publicized through their network. And then we got some people, enthusiast people engaged. And once they send their contact details, then we will actually we have created a lot of videos for the lay people to understand what this is all about, and then they watch the videos, and then they come to the particular measurement time of the day throughout the summer, which is January to February. And we have also created this kind of data collection sheets, people to see what is at this point, what is the temperature, what is the humidity, and what kind of the metadata is very important. Like if you're measuring temperature, what is is it a sunny space, is it a shaded place, what kind of surface dark, if it is a grass area, is it irrigated grass, is it dry grass, or is it partially irrigated grass, things like that. And we created some walking maps, walking route for the people in strategic areas around the council building. And that again, that really depends after discussing with the council and officials. They suggest us, okay, this is a good area for people to come and go around, and then they walk around and then try to understand the differences between various points. And also they focus on some particular area. So this one example of a street, and then there are buildings on site. There is footpath, grass, shaded trees, etc. And there are cars also parked, given to see, what is the difference between the microclimate in that area. And this was, one of the most in demand equipment, like an infrared gun. People were trying to go around and looking at, why is that? What will that color do in terms of temperature reduction like that? So initially we got a lot of people who are retired because they have time to contribute, and then we got a lot of interest from schools and science teachers and students who are doing their projects in the year 10, year 9, year 10 kind of classrooms. And so this is the map of Australia, what I was going to show you. So these are the places we have actually tried to, do the climate is very different throughout the whole area. So we were trying to, and inside, most of the settlement in Australia is along the beaches, and the inside is very hot, uninhabitable. So we tried to cover all of them, and then even we had, the minister was very interested in the ACT, and this is the Minister for Climate Change in the ACT government, and this was the mayor of one of the council who was very interested and come and do this whole and sometimes the politicians are very we have to work very strategically with them, because what they are interested in, how do I win the election next time? So how do I make my people happy, and how do I show that I'm really interested in your problem? So this is how we engage, so that we have like each of those boxes can actually engage 40 people, because you have, infrared gun, a notepad to measure. So we have maybe 40 people to do one box. So it was limited, the number of people we could engage in a day, but there were some councils people more than what we could actually engage, but we still try to spend extra time. And some places, and not so many, and sometimes even though 50 people say they are coming, only 50% of them will come on the actual day because it's not a paid service or anything, so it's their time. And we were trying to map out the temperature and then try to map the difference between the local Bureau of Meteorology station and this measurement they have done. So you can see some of them, could go, this particular space could go even more than 70 Celsius compared to tropic. Because, so the idea is, the Bureau of Meteorology, or what you see in the weather station is not the actual representation of the microclimate of your area. And if you have an air conditioning, which is actually taking air from that particular area, it's actually the energy consumption is very much depending on where the fresh air inlet is. And if you just estimate the data or energy consumption based on the Bureau of Meteorology, you are under predicting energy consumption. So this kind of data is very important to make accurately predict the temperature. So these are our engagement with schools. So there were students were very, very enthusiastic to understand. And there is nowadays, there is a lot of examples of people completely taking out the grass, natural grass, and using artificial grass in the vicinity, mainly because it's very difficult to maintain the grass. We have to, every month. But our experiments show that the artificial grass on a whole day can go up to 70%, which can really, really be dangerous sometimes if you try to the small babies. And also the playground, some of the playgrounds using the rubber, synthetic rubber, they were also very, very hot during the hot days. So similar engagements are not really going into details. Yeah. So we also created a thermocouple tool with the measurements. Again, people can use our website to input all the data they have actually measured during the measurement, and can find out, what is the comfort indexes, whether we use a universal thermal climate index using the physiological temperature model to predict whether it is really high, extremely high heat stress, or it is something moderate, or is it, dangerous. So we also created I was talking about the low cost sensor. So we created an app which people can work along with the small sensor. So this is how the sensor looked like, and we created a Stevenson sheet kind of equipment, make sure it is covered from solar radiation. And what people have to do is, they just install the app and just put this equipment next to the app and then start an experiment, which could probably be, 1 or 2 days or up to 3 days. And then you can take your phone anywhere, and then you come back and then connect it again. Then you got the data for half an hour temperature humidity data for last 24 hours. You started the equipment. And then what comes next is basically you can, in the app, you can input all the information, like what kind of an area that is, what kind of location this is, and what there are any special features which is going to impact the climate, and what kind of wind conditions are there. And once you collect all that data, you could pick a Bureau of Meteorology station, which, closer to your home. In case you are staying next to Sydney, you are staying in Melbourne, and you can pick up a weather station, and then you can actually plot the temperatures. What you see here is your sensor, and then 2 other reference stations near your area, and how the temperature is actually. You can see this is actually cooling down during the night, but this one is not really cooling down because of the impact of the wind environment. And we have also done a mitigation tool for different councils. So this is basically, what I have shown is just for one particular small area. So if you a council want to see in Sydney, what kind of mitigation strategies is good for that particular climate, whether it is about, using water features, or is it about using trees, or is it about using cool material? They can actually input and then get a broader view of how much cooling is going to happen by that particular mitigation strategy. So I was just trying to think about, how do you translate that into the Indian condition, and which, what I have seen over the last 20 years, like nobody could afford an air conditioner many years ago, but now it became like a normal electric bulb or, a ceiling fan. And some studies have actually shown how much the vegetation area in Chennai and Bangalore cities have actually reduced, and then the water bodies and the air conditioning, how the demand and the actual usage has increased, and sometimes even the efficiency. There are two things: the energy consumption using these air conditioners, and also the impact of that energy, the heat output it's kind of a cycle effect. One is causing the other, and it's just keep building. And if we don't really act proactively, it's in the future it's going to be really the grid. The electricity supply will not be able to address the demand. So the cooling demand is predicted to increase 750% by 2050. And that, if we are still going for the traditional kind of power, 300 new coal-fired plants, that is what is required. So I just want to, I don't know how we are going on time. So I talked about the indoor air quality project we have been working on in the last few years. So this was a project funded by the state government of Victoria, looking into how do you improve the indoor air quality for vulnerable population. So when you talk about vulnerable population, you're looking at people in two different age spectrums: people who are really old and people who are young. And if you look at young people, they are still developing their respiratory capacity, and whatever happens in the early stages of their life is going to have a long-term impact on respiratory diseases and other kind of diseases. And if you look at schools here in Australia, in most of the schools here, when my young days, they were all naturally ventilated, and I don't know whether things have changed. Maybe there are different types of schools. So the air quality issues, when I was just looking at the project we have here and the issues there, the air quality outdoor is quite good in Australia most of the time. And you have these occasions when there is bushfire in the nearby forest, which is actually through the wind force, the Melbourne, Sydney area, they can really impact from the smoke of the bushfire. So there are few times in a year these things, extreme events will happen, which is going to, that's when everybody think about, indoor air quality, not air quality. But the people spend up to 90% of their time indoor, and most of the places in Australia are air conditioned. Air conditioned doesn't need ventilation. So we talk about heating, ventilation, and air conditioning, but people forget ventilation. It is only heating and air conditioning. And for example, the split units here, doesn't provide ventilation, just provide cooling. You don't really need heating here because it's always hot. But things like, areas like Melbourne, it is a heat-dominated climate, so you need to have heating. And nowadays, due to climate change, you need cooling also. But traditionally, schools are supposed to be naturally ventilated, but now people became more affluent, while sensitive about thermal comfort. All the schools started putting air conditioners and heaters, but forget about ventilation. And that's where the problem is coming. So the project initially was about how do you make sure there is a lot of pollen in the air, particularly if any of you have traveled to Australia during the springtime. And if you have some kind of an allergy, you can get really affected because of the pollens in the air. So the project was about how do you make sure all those, pollens and things like what kind of strategies we can adopt to make sure that those kind of pollens. And there was an event, it was really high temperature and very windy, and we call it like thunderstorm asthma. So many people, like including one of my daughters, she suddenly got very sick and didn't know why she's complaining, and she never had any asthma, but that incident triggered asthma for so many people, and many people got hospitalized because of that. So these kind of events can trigger issues for people who are generally healthy. So that was the whole idea of the project. But by the time we collected data, COVID started. So the whole thing actually changed. It was about, how do you open the door, let the fresh air come in, whereas we were trying about how do you close the door and then filter the air inside. So you need to be really prepared to see, the research problem actually keep changing. And you need to be very resilient to address the issues. Not saying, no, I'm not interested in the opening windows, but that's where, if you remember, many of the researchers actually looked into. Initially, they were not really accepting, the WHO were not accepting that COVID is an airborne problem. People were actually focusing on touching surfaces, how do you avoid touching surfaces, but later this was that was really a good thing that people accepted. So we are looking into the schools and aged care centers, because most of the population, I think 65% of the population, more than 16% of the population is aged 65 years. And we all get aged at one point of time. Maybe I'm sooner than you, but everybody with age. And then the aged care center. So people who are old, they mostly prefer to stay in aged care homes because they are, due to their lack of mobility. And these people, they spend 100% of the time indoor, right? And they don't go out because of their mobility issues. And so they can be highly affected by indoor air quality, and they are affected by, if let's say our exposure level is really affected, let's say 1000 ppm, but their exposure level is affected even at a low concentration of pollutants. So they have a very high chance of developing various respiratory diseases. And if you look at the students, they spend at least 25 hours per week inside the classrooms. And that is basically, 1075 hours in a year. We were trying to develop some kind of a system, not developing, but using some kind of a system to see, whether in what kind of interventions can be useful to improve the air quality. And before that, understanding the baseline of air quality data in schools and aged care centers. So we partnered with a manufacturer and who is supplying the fresh filtered ventilation system, and also some aged care associations, and also the building authority and the Department of Education. And did like a whole year monitoring using carbon dioxide concentration level, particulate matter, and also we looked at pathogens including mold, bacteria, things like that. And we also looked at subjective aspects, how does the air quality impact students' well-being, students' performance, and how do you measure those performance? And there are different ways of doing that. You can ask self-reported survey, or you can have health indicators, you can have academic performance indicators, well-being indicators. And this is where, I'm very happy to hear that you have collaboration with the health department and, medical colleges to see, we really cover the subjective aspects too. So some of the, so actually we spend a lot of time in getting permission from the schools, and we have to make sure the principals are interested. At the same time, the school teachers are interested and really, making sure that it is not disturbing their classroom attendance. So we have some kind of monitors which is installed on the wall, and also some kind of big equipment which is basically installed in between the classrooms, and also the external measurement for particles too. So this is how the schools view of the schools there. So it's basically closed, completely closed, and some of them are double story with a corridor and two sides classrooms. And this is a view of how the aged care centers look like, and they are more vulnerable than the school children, because some of them are really not capable of expressing because sometimes when we were talking to them, we started to do a survey with the aged care people and asking them, how do you feel? And they were really scared. It's all good, I'm so happy here, because they're thinking that if they complain, they will be kicked out of the place. So it was very difficult. But then we decided, okay, there is no point asking them about their perception about air quality, because it's not going to be accurate. So then we tried to get some kind of hospitalization data, and but all that needs very long-term monitoring. It cannot be just one-off monitoring for hospitalization. So we learned a lot, even though we didn't really, not completely satisfied with the work. We learned a lot from this project, which we could apply in other projects, and also trying to see, the kind of construction, how that is going to affect, and then the reverse cycle air conditioning, that is the split systems you have here. And also the type of materials, some of them are brick walls, some of them have the lightweight construction, things like that. And we try to do a measurement like 6 months in the whole year, first 6 months, without doing any intervention. So the idea is to actually install a fresh filter ventilation system in the ceiling, or sometimes it has to be outside, depending on how they design the system, and then see how this system is actually improving the ventilation in the classroom, and then do after 6 months of data. So this is the small equipment, and again, the doing the project, we found out we didn't really develop this in-house. We just used an already developed system. We found out, many manufacturers probably claim that this system can address the issue, but some of them not really up to the standard. So the air conditioning, the indoor air quality, normally people use carbon dioxide concentration level as a surrogate of air quality, because that is a tracer gas and very easy to measure. And if you know the carbon dioxide, but that carbon dioxide itself is not a pollutant. So carbon dioxide is just going to give you the ventilation in the classroom. So if it is really low, there could be other pollutants. So just using carbon dioxide as a pollutant is not really the right way to do. And then we have noticed during COVID time, this has become like a Bible for most of the people. And people were using any types of, if you see 800 ppm, then people start really getting alarmed and start to leave the place. So it's basically really understanding, what does that 800 mean? So 800 means basically the difference between outdoor and indoor. So we normally use around, previously outside carbon dioxide concentration was around 350, but last few years or last few decades, it's gone more than 400. And so it's basically the difference between indoor and outdoor. So anything, you see more than 1000, that's when it's low air quality or low ventilation rates. And there are standards from ASHRAE for that. And we tried to see the temperature, humidity, and then found they were all within the standards for temperature, and there were some peaks. That's when, the weekends, and sometimes the teacher left it open, the doors were not closed, things like that. And relative humidity was also within the standards. And we found we found the carbon dioxide concentration quite high. Some of them, gone up to this was the aged care centers. Aged care centers was quite okay because they are all air conditioned with ventilation, but the schools were very much more than up to 5,000 ppm, and that's when during the midday when all the students are there, 20 to 25 people with one or two teachers in the classroom, everything was closed, and that's really going to impact their health. And we tried to calculate the ventilation rates using the normal steady state method, but the interesting part was we don't really have such a high airflow, and you can't really use steady state method if you don't have high airflow, but still that was the only option for us to use. And the ventilation, the standards actually say 10 to 12 liter per second ventilation for schools, and we found 7 out of 10 of the classrooms ventilation rates below the standards. And we also looked at particulate matter in the classroom, and we find in a relation. The activity of the school children, and if it is a carpenter school, when people move, the dust level really go up. And we couldn't really do much of a controlled experiments to eliminate most of the variables. Maybe particular in the above or below standards requirement. And again, the different quality standards, not standards for output air quality, but the guidelines for indoor air quality is not there. So we always use outdoor air quality as a guideline for indoor air quality. So this was an interesting thing. How do you actually measure the students' performance in the classroom? One way to do that is doing their academic performance, right? But there are so many things affecting their academic performance, not the air quality. Probably some of them are inherently smart, or they come from different socioeconomic conditions. So we try to do a D2 attention test, which is basically giving them a sheet where you have, a B and D and the so many ticks here, and then asking them to cross out a particular letter which has got two lines in the bottom here, or one line in the top, one line in the bottom. So it's really measuring the attention span. So we give it to them and then ask them to do that within a few seconds, and then collect that data and administer that in the classroom, and then see what kind of errors, and do a lot of statistical analysis to see how many numbers of errors they are making in that exercise. And there are equations to measure concentration performance from these values. And we found that there are certain parameters, for example, relative humidity and mean radiant temperature, which is basically the temperature radiating from the envelope, and also PM2.5, which has got some kind of a predictive influence on the performance of the students. Not much of the carbon dioxide concentration level. So as I said, the findings from this study was the ventilation rate ranged from 1.6 liter per second to 11.5 liter per second, whereas the standard was 10 to 12 liter per second, and 7 out of 10 classrooms showing ventilation rates below the recommended value. And so there have been a lot of short-term interventions people were doing. So after COVID, what happened was all schools in Victoria were given portable air filter, something like a fan which you can breathe here, and which is so again, that is not really that is just recirculating the air inside the classroom, and it's not really taking out the pollutants from there. So all the schools had portable filters, and everybody opened the windows and doors, but there were so many schools because of the traffic, proximity to traffic and proximity to industry areas who were not able to open the windows because it was more polluting and then more noisy. People could not concentrate because of that issue. So the idea of having just one way of addressing the problem will not work for all schools. And then the mechanical engineers, they were trying to fix this problem by using various different methods of putting air conditioning. So as I said earlier, this kind of system don't have the ventilations. Ventilation just either heats or cools the room. And there was no ventilation standard. So the problem is you open the windows during very extreme cold regions, students really impacting their comfort. And we tried to do, so the study found that, you can't rely on natural ventilation anymore. And the mechanical ventilation should have ventilation in addition to heating and cooling. And we tried to do, how do you actually optimize the cooling, the ventilation and thermal comfort for the people. And you can, this is a study using computational fluid dynamics and trying to see, different kinds of, how do you actually put your air inlet and how do you put your air outlet, and how do you make sure people, sitting in this area, this show the student locations, and this show the ventilation system, and these are the inlet. And we tried to do actual conditions in the classroom. How do you what kind of equipment they are using in the classroom, and how can it address peak summer, peak winter. And most of the summer is not much of an issue because the schools are closed for summer holidays, but it is the winter period, which is, if you look at the Australia southern hemisphere, it is summer out there now, and in June, July is the winter period. And we try to model various scenarios, looking into, the outlet location, the inlet location, and also, try to put 2 outlets instead of 1 outlet and 2 inlets, things like that. And then trying to see, the temperature variations and summer and winter. And what we found is winter is very, summer is okay. Only you have some issues near the envelope where using single glazing for the windows. So summer is a bit of an issue only here, but not in this area. Whereas winter temperature can be very bad. You're getting around 70 degrees Celsius, which is quite cold for kids. And try to do a predicted mean mode, which is an indicator for thermal comfort. And you are seeing, -3 means too cold, -2 also is cold. And whereas here you see, 1 is towards the neutral temperature, where a body can actually take that. And we also try to do the particle tracing and see how the air is actually flowing inside, and different variations. Some of them, what you can see here is, the issue, one of the potential issues is condensation, when you have cold and hot air actually touching each other very immediately, that can cause condensation issues. So we thought some of those scenarios performance is not that great, so we could not use those kind of scenarios. And then the result was basically, the ideal thing would be using preheating the air coming inside rather than just getting the cool air ventilation coming inside for fresh air. So basically, we were trying to open up certain places for the air to come in, but the schools don't really have the budget to pay for the air conditioning or heating bills. So they were trying to do very low cost kind of system. So finally, do a bit of a preheating before coming inside. That was one of the solutions from this CFD simulation. And we have a new PhD student actually looking into, because if you want to really do simulation for CFD, it takes, I don't know how many of you have done any familiar with CFD simulation, but it can be very, time consuming. And how many scenarios you will create, this one study only did 7 scenarios, but you need multiple number of scenarios to come up to a conclusion. So the modeling work, what we are, the two ways of modeling is, one is physical modeling and the statistical modeling. And physical modeling is what that I have just explained. And the statistical modeling using the machine learning algorithm is what the study is going to be. And for that, there are so many indoor air quality parameters. You can look at particles, you can look at gases, you can look at other things. But how do you, what is the most important or most representative of the air quality component in terms of schools? And then there are a lot of pollutants actually being created inside the classroom, from students and also from teaching activities, the chalk or the coloring, those paints, things like that, creating even VOC. And how do you actually develop predictive model, looking at the indoor and outdoor interactions for predicting the air quality? So you don't really need to go and monitor in the classrooms, but by knowing certain aspects, certain characteristics of the classroom and building and the weather condition and the outdoor, conditions, people can predict whether it is school located in this area, what is like, and at what condition, if there are extreme situations like bushfire smoke, what can they actually do in terms of interventions? So the methods for improving indoor air quality, either you control the sources or you do natural ventilation or you use filtration. And the predictive model can actually look at each of them and create, some specific customized scenarios, interventions depending on the schools. So the idea is to look and focus on different kinds of locations, the area next to the traffic and industrial area, and also the area which is affected by wood smoke, and that is only happening mainly in some of the regions. People during the winter time using wood to heat the created heat, and that can create a bit of air quality issues during that time. And we also want to focus on the extreme cases like bushfire smoke, but you can't really hope for within the PhD period that such incidents. We don't really want to hope for that, but so we're trying to focus on wood smoke area at that time, and also a normal suburban area, normal school without any pollutants, and trying to still working on what would be the best indicator, or can you just create an air quality index for schools using selected pollutants. And if you have limited number of equipment, what should you measure? Because measuring gases can be quite time consuming, and if schools don't really have the capacity and we can't be going around and measuring all those schools. So how do you actually select the representative schools is a problem. So the studies just started, so looking into the all seasons, what happens in summer, winter, spring, where the air quality can be a big issue, and traffic area, and then how do you actually develop those evaluation scenarios? That's what we are going to. Yeah, that's all I have to talk to you. So thank you for your attention. If you have any questions.
No questions, maybe I'll start. It's very interesting to look at it. Particularly, I was experienced with engaging the citizens and equipment, and then they will fascinate. They will the one where they feel that okay, how important. In that context, if you just said this, all these instruments were made in the lab. The city council will be participate this, and can we replicate this in the other places, like for example with this with our real context.
Yeah.
Can we explore that? So what do you think?
Yeah, definitely. Because when we started this particular project, we didn't really think about what impact it is going to have. What makes me really happy is even now after the project is completed, I still get emails from school students who somebody has recommended this project for the students, and we still have those tiny little sensors, and we send those sensors to the students, and they keep interacting, and they ask us, is that okay? Is the results make sense? Things like that. And the videos we have created, at that time, I didn't really think about how valuable it is going to be. So they are still there in the website, and then sometimes you don't think about the maintenance part of the website. You still have to pay money to maintain and keep the website. And sometimes I think, oh, do you really need this? Can I move on to other projects? No, then you get this question from somebody, oh, do you have, how do I use this equipment? And then I can always refer back to this website. Video number 1 is talking about what is the science behind it. Video number 2 is talking about how to use the equipment. Video number 3 is, so it's all there, the resources. So you don't really need to do any extra work. And the equipment, we still send it around to other cities within Australia. The equipments are there, so there is no extra work is required. We just need to probably communicate that to the interested parties. So just need to create the experiments customized to their needs, but the basic things about, equipment, videos, communication channel, everything is there. So it's very interesting to, how you translate to in conditions.
Just there is one online question. This is about some of the air pollutants and interest in the environment is that's all critical. I mean, what is important is how do we relate which pollutant in the outdoor environment and the indoor environment, because you did mostly with that. Maybe trying to look at it from the comfort aspect also. So do you feel that, because you also pointed out that which pollutant to be measured if there is a resource constraints. So in that context, if somebody wants to start a research, we have some suggestion what they should look at it.
Yeah, I think particles has been studied quite extensively all over the world, mainly because they are easy to measure. And the PM levels, there are so many kinds of low-cost sensors, which you probably just pay $200 and get a sensor for particles. But it really depends, I mean, that's what we are challenging for us at the moment. Like, if one school has got more VOCs, or one school has got more NO2 or SO2, is that representative? And what if, are we going to find 4 schools completely different kind of pollutants? And how do you translate that into a school somewhere other parts of Australia? So we're really struggling to measure the gaseous pollutants without having a proper set of instruments. Here we can measure and we can do all kinds of calibration. So I think it really depends on the context and understanding how the schools are basically what kind of pollutants are generated within the school, and is that actually creating any secondary pollutants? So still not very sure at the moment.
So with a follow-up question, do you have some indoor air quality standards in Australia for different environments like elderly care units, or maybe for schools, or maybe residential area?
The standards are all about the ventilation rates, not about pollutants. But they just say what should be the ventilation rate per person. And that's why we, as I said, we are relying on the outdoor environmental quality standards for indoor environment. It's basically the heating, the air conditioning standards for ventilation.
It's an interesting question. I do also start thinking about it because several years back when I had an interaction with one of the architects, they says that the south winds are not good because that will bring a lot of the bad air. I don't know what is the reason for that. In the same, I started thinking about how do we orient our buildings, and particularly school. If you assume that classroom schools, we spend a lot of time and we need to be designed them properly. And when you come to home, then again we will be there for 24 hours, at least some of us, because sometimes we go work, maybe we will not be there in the home. So how do we orient this, considering the geographical location, and sometimes we construct our house only for 2 stories, and all of a sudden the neighboring comes with a tall buildings, then it automatically affects the microclimate and air circulation and indoor air quality. So how do you look at it from the design aspect? What should we do?
Yeah, so I think in any, if you go through the fundamental principles, you start with a site analysis for the designs. That's where you look at the climatic conditions, what is the maximum minimum temperature, what is the wind speed, and prevailing wind direction, which is very important. Like when I go back to my home, I feel, for some reason it is really very, very well orientated, and you can from the front yard, you can really feel the wind coming in. That's just because somebody did a study about the wind in that area. And basically, in climate, we have a prevailing wind direction. So if you look at Australia, you have northerly wind and southerly wind. So the northerly wind come from the desert, and the southerly wind come from the Antarctica area. So it can change, the wind direction can change drastically. So there are in Melbourne, there will be time when temperature at 2 o'clock is 40 degrees Celsius and 3 o'clock suddenly changes 20 degrees Celsius. That's just because of the wind direction is changing. And it really depends on the context. And normally we do like a preliminary, if we have resources, do a preliminary CFD study to see the prevailing wind, and then you can orient your windows in that direction. But again, as you said, if some neighbor put another building next to that, that is going to completely change the wind direction. So it's not that big.
I think this is a very interesting question. And there is one more last question. We'll try to look at it. And can you throw some light on whether phytoremediation technology is utilized in Australia to mitigate indoor air pollution, as it is now being promoted as a more sustainable approach? Phytoremediation, because I've seen that people used to put some plants, indoor and plants, and to address some of the indoor air quality. Do you think that this also Australia is more promoting such things?
I think in Australia they are mainly used more like a beautification thing and more like a biophilic thing for people to look at, for visual comfort rather than air quality, because that could increase the humidity inside the room, and then that could also create other mold and that, those kind of things. So it's not really looked at as a air quality, other than the dust particles could be, deposited on the plants, but mostly for visual.
Time and yeah, thank you very much. We'll have one quick group photo. We sit there only. We'll ask when you can come here. I also all the online participants to start your camera. We will try to collage the photo.
Thank you very much for
Yes,
listening.
please. Some of you can just join here so that we'll try to reduce the. Just come here. Some 2 seats are here. We can just this other side. We can also stand so that we can. One photo you can directly take it from here, then another one. Everybody can start your camera. Okay. Gopika, you can take the screenshot in that itself. One of it. Yes, so some of you can just start your camera so that you just. Okay. Done. Yeah, thank you very much. Thank you very much for joining this talk. It was an interesting as a year start. We'll see if we can do a lot of things for the air quality management. So on behalf of IIT Madras, also for the Air Quality Management Association, representing all of you. I like the way you acknowledge your indigenous community. We also represent indigenous and Indian origin. So we'll thank you all for taking your time to give this talk. So we'll have a sound memento at this end. This is thanks all of you for joining this talk, and we'll keep engaged. Okay, so we got now a lot of ideas. We'll move forward. Okay, thank you all. Yes, we have arranged a tea and.